AVL tree deletion. Suppose this tree is given. So first we will cross check the balancing factor of this. So 16 there is no child, so balancing factor is 0. 18 there is one child on left hand side, so plus 1. 28 there is no child, so balancing factor is 0. 39 there is no child, so balancing factor is 0. 41 there is one child on left hand side, so plus 1. 26 there are two childs on left hand side and one child on right hand side, so plus 2 minus 1 plus 1. And 37 there are 3 levels on left hand side and 2 levels on right hand side, so plus 3 minus 2 plus 1. So tree is balanced now, we are able to see, because balancing factor are 0 plus 1. Now suppose if we delete 39. Suppose if we delete 39. So what will be the tree now? So the tree will be like 37, 26, 41, 39 because deleted, so we will not write it here. Now 18 and 28 and 16. Now again we will cross check the balancing factor because we have deleted 39. 16 there is no child, so 0. 18 there is one child on left hand side, so plus 1. 28 there is no child, so 0. 26 there are two child on left hand side and one right hand side, so plus 2 minus 1 plus 1. 41 there is no child, so 0. 37 there are 3 levels on left hand side and 1 level on right hand side, so plus 3 minus 1 plus 2. So now we are able to see, as we have deleted 39, so here the balancing factor of 37 is plus 2. So now we are able to see that balancing factor are not correct in AVL tree, because the balancing factor can be either 0, plus 1 and minus 1, but here plus 2, so we need to do rotation. And as we have discussed in the last lecture also, this node, the root node is considered as A and the nearby to root node is considered as B. The root node is considered as A and nearby to root node is considered as B. So whatever is the balancing factor on B, as we are able to see, it is plus 1. So this is known as the rotation. So this is known as the R1 rotation. Again we will see the root node is considered as A and the nearby node to root node is considered as B. So whatever balancing factor on B, that will be considered as the rotation. So now we will do R1 rotation, because we are able to see the balancing factor is not correct over here. So we will do rotation, that is known as R1 rotation, because of the B balancing factor. So now we will rotate the tree from B. So it will go up, 26 will go up, 37 will go down. Here in deletion, if it is R1, so we will move left and right hand side. If it is L1, then we will move left hand side. Again we will see, because here we deleted from right hand side, so based on the right hand side deletion is there, that's why it is known as R1 deletion, and because on B plus 1 factor is there, that's why it is R1 rotation. Suppose if it is L1 rotation, so we delete it from left hand side, that's why it is L1 rotation, and whatever value on B value, that according to that we will shift the tree on left hand side. So that is the similarity between R1 and L1. In L1 we will delete that node from left hand side, in R1 we are deleting the node from right hand side, as it is clear that 39 is on right hand side. And after that we will cross check the balancing factor of B. Here it is on left hand side, and because we are deleting from right hand side, in L1 it will be on right hand side, the B factor is, it will mean same. So R1 rotation will be on right hand side and L1 rotation will be on left hand side. So we will see here. Now we are rotating according to R1, so 26 will go up. So we will see here, 26 will go up, 37 will go down, and after that 41 will come. And after 26 what is there? 18 is there, so 18 will come. And after that what is there? 16 is there, so 16 will come. Now one node is left, only 28, because we are rotating right hand side, so 26 will go up, 37, 41 will come down, and 18 and 16 will come over here. Now 26 is the root. Earlier 37 was the root, so 28 is coming here, because we are following the binary search tree property. So whatever nodes are less than the root node, that will come left hand side. Whatever node are more than the root value, that will come on right hand side. So earlier 28 was on left hand side because 37 was the root. Now the root is 26, so it can't come on left hand side, it should come on right hand side. So we are able to see 37 node is there and 28 is less than 37, so it will come on left hand side of 37. Again we will see here 28 was less than 37, so that's why it was on left hand side, but now root is 26, so it will come on right hand side because 28 is more than 26. And again we have root 37 and 37 is more than 28, so we can say that 28 will come left hand side of the 37. Now we have done the rotation. After rotation, again we will cross check the balancing factor so that we can say it is corrected AVL tree or not, or we need another rotation or not. So again we will cross check 16 because there is no child, so 0. 28 there is no child, so balancing factor is 0. 41 there is no child, so balancing factor is 0. 37 one child on left hand side, one child on right hand side, so plus 1 minus 1 0. 18 there is one node on left hand side, so plus 1. 26 there are two levels on left hand side and two levels on right hand side, so balancing factor is 0. Plus 2 minus 2 0. So now we are able to see the balancing factor are plus 1 and 0, so AVL tree is balanced. So in this way we can do R1 rotation in the case of deletion when we are doing deletion on right hand side and the B value is plus 1 over here.